Hello there, everyone, and welcome. It's Professor Thayer, and I'm here with you today to go over your exam one. So just to be sure we're all clear on where I got the exam from and to make sure you have the same one, because there are two practice exam ones, I will show you where I got it, and then we will take some time to go ahead and go over that with you step by step. So I'm here on my touchscreen computer. So what I've done is I've actually gone there and I downloaded a PDF and opened it in OneNote. So I'll be able to share my screen and write on it with this pen, just like we are solving it in real time, hopefully. So let's get to it. I'm gonna go ahead and share my screen. Share. Screen sharing. And next, what I'm gonna do is show you how I found my stuff. Sorry. Okay, so the way I found it was I went to our Google Drive. And yeah, all kinds of Zoom controls blocking the view here. Okay, went to Google Drive. And all right, so when I got to the Google Drive, I was not here, but I went to this link. This is where your Google Drives live, where your documents live. Then what I did next is I went to practice exams. And in here you see that there's actually two practice exams. So exam 1 old is an actual exam that I gave a couple of seasons ago. And this is practice exam 1, which I made just a few months ago in the spring semester, which yours is very close to this one. If you only have time to do one of the exams, I'd recommend this one. Sometimes the formatting doesn't appear correct. So on the Word documents, I've also made you a PDF version of the same thing. They're the same test. So I downloaded the PDF version and here's the solutions for them. And also I have an accompanying study guide for you, which I hope you find helpful. All right. So let's go ahead over here. I'm actually gonna just flick this. I think actually you don't need to be looking at my smiling face anymore. Let me see if I can turn this off. No. Okay. Well, see. Hopefully you should be able to see my screen. Let me put those down. Now, let's take a look at the exam. So what I've done is I have gone ahead and downloaded that, and here it is. Zoom controls on top of it. Wonderful. Okay, so on the instruction page, let me just get some kind of a pointer here. On the instruction page, make sure you read over. Whoa. Nope, that's not what I wanted to do. This should be a pointer. Okay, on the instruction page. Oh, wait, is it not work like a pointer? Okay, looks like a pointer if I'm not pointing on the page. Okay, but what you want to make sure you do is that you read over all these instructions. You can read this one ahead of time. They are identical, if not nearly identical as the ones on yours, so you just know what to expect. Please make sure to do the no aid, no violation section, which is right here. So I can write on it with this. Okay, that's good. Sign your name and put your West ID. So that's on the front page, so I won't be able to tell whose it is. Also, please circle your section number. That really makes it a lot easier for me to look it up if you have used your West ID and your signature is not readily readable, which sometimes is the case. All right, so please do that on your real exam. Now we're going to look at some of the true and false questions. All right, so true or false? Let me just switch to a pen here, like I were taking the test. All right, so functions must always contain at least one explicit return. That is false. And the reason why that is false is because we know that there could be such thing as implicit return. So false. Next up, the expression 5 plus true evaluates to 6 in Python. Yeah, this is gonna be a coercion. So you remember that true coerces to 1 and false coerces to 0. So what Python will do when it attempts to evaluate this is it will attempt to cause true to be the integer value, which it coerces to 1, and that gives you 6 as the answer, which is a true statement. Okay, let's make sure that matches our answer key. Yes, good. String indexing in Python starts at 1. No, it doesn't. String indexing starts at 0. Starts at 0. The ignition in the branch guard is checked before the execution of the loop body. Yep, that is a true statement. Branch guard is evaluated before we begin the execution. If it's false, of course, the loop body will not execute. All right, let's go to the next one. So now we're going to take a look at the multiple choices. So notice that there are opportunities to answer 3 of 4. So you should watch for this on your test. You may have options for what you can answer. So circle the best answer. We'll go ahead and just answer all of them. But if you do decide you want to skip something, if you can kindly just X out the problem, especially if you've opted to answer it before, so that I know which ones to grade. So if you don't tell me, by default, I will grade the first, for example, in this case, the first 3 out of 4. All right. Which of the following is an acceptable variable name in Python? Okay, let's take a look at what the problems here might be. 3 number. No, that starts with no. This one is a no. Can you go to write mode? No. The problem right here is the 3, right? Okay, username. That looks fine. Value at. This is a problem. That's a no. And while is a Python keyword, so that leaves us by process of elimination. B. All right, what will be printed by the following code? So let's make sure that, we've given you the correct answers. Okay, I agree. B is the first answer. Okay, 6. Now, here we have x gets the value of 4, y gets the value of x double squared divided by floor division 3 plus 2. Okay, so the order of operations and then print y here. So let's make a little variable table over here. X gets the value of 4, y gets the value of, all right. Well, we gotta do some math here. So let's just take a look at this. So we have x double star 2 / 3 plus 2. Right, so what takes precedence here? This one is first. So in the next line we would do, all right, so we're gonna substitute in 4 raised to the squared power divided by 3 plus 2. Okay, 4 squared is 16, double slash 3 plus 2. So the next thing that we do for the order of operations is we do this line here, 16 double slash 3 plus 2. So just like we did on the homework. So the floor division of 3 goes into 16. 3, 6, 9, 12, 13, 14, 15. 5, it goes in 5 times evenly. Plus 2, and then we add 5 plus 2, and we get 7. All right, so I think the answer is 7. So I'm gonna pick answer choice D. It will let me write on this. Not moving, but writing. There we go. D. Okay, B, D. Okay, next it thinks the answer is A. So what happens when the following code is executed? Greet, print hello, result equals greet and print result. All right. Okay, so let's trace this all through with what is happening here. Okay, so here we have a function called greet with no dog strings on it. That's because I'm not telling you what it's returning. Next, it's going to print hello. And notice here, so what I'm noticing here is there is a return none in here. So I'm just thinking about that, right? So the signature that I'm thinking about is none type to none type. So I'm keeping that in mind as I'm looking at this. All right, so when we execute this, then we get to result, gets the value of executing greet. When greet executes, it prints hello and it is returning none. So result gets the value of none, and then we print result. Well, what's result? Well, it's none. So you see how I worked through this before I looked at the answer, so I'm not being led astray by any answers that may be incorrect but gives reasoning that sounds correct. So I think what happens is first it prints hello, and then what happens is it prints results. So it prints none type. It prints none, not none type. It just prints none. None type is the type of that. Oops. Okay. So anyways, now let's see if any of the answers actually match this. So hello is printed followed by none. Looks pretty good. Hello is printed twice. No. Hello is only printed once. None is stored in result. I agree with that, but nothing is printed. Well, we print result right here, so that's not correct. The program produces a syntax error. No, I don't see any reason why that would happen. So the correct answer is A. All right, next, so we take a look at is number 8. What will be the output of the following code? Fruit equals banana. Now we're going to be doing some slicing. Now, keep in mind that we are going to be starting when nothing is showing. We start at the beginning and we go up to but not including 3. And here we have a -1, which is going to take the last thing. So already I can look at this and say it needs to end with A because -1 is A. So I can already say this one is wrong, this one is wrong, and this one is wrong. All right, so the answer is probably A, but let's just confirm. So up to but not including 3. 0, 1, 2, 3. So it looks like BAN plus A is what we're adding, and that is answer choice A. Great. So then just to recap, the answers for the multiple choice are B, D, A, A. And that is what the answer key says. So super, it all agrees. Section C. Let us take a look at this one. So we have some descriptions down here and we have some questions up here. Match each term related to loops and conditionals with its correct descriptions. We have iteration, infinite loop, break, statement, Boolean expression, while loop, and if-else statement. So keeping those in mind, let's go ahead and read through the descriptions and see what might match. So a control structure that executes a block of code repeatedly while the condition remains true. That sure sounds like looping of some kind. That one looks like a while loop to me. So let me go ahead and put an A there. This will let me. A, good. Okay, so that one's done. I'm going to cross that off. A loop that never stops executing because its condition is always true. That's an infinite loop. That goes here for B, so I'll cross this off. A statement that immediately exits a loop, skipping any remaining iterations. Okay, this sounds like the break statement. So notice that return also can stop the execution of a loop, but of course only if you're inside a function. A condition that evaluates either to true or false used in loop decision making. This sounds like a Boolean expression, actually the branch guard. So I'm going to go with that as closest to answer choice D right here. A structure that chooses between 2 different blocks of code based on a Boolean condition. This is an if-else statement. So notice that the if block may not execute, so that couldn't be that answer. So well, we don't have that choice either. But when you have if and else, that means that you could, you're guaranteed to have something run. That's what I'm trying to say here. Okay, E goes here. Next, the process of repeatedly executing a block of code either for a fixed number of times or while a condition holds. This is iteration, cycling over things several times. So that goes up here. All right, now let's just double check with what I told you. F, B, C, D, A, E, which agrees. Excellent. Okay, match each type of if statement with its correct description. All right, so we have if statement, if else statement, if elif else, nested Boolean expression. It's not exactly an if statement, but it pertains to it, and comparison operators, which is not actually an if statement, but yeah, you get the idea. Okay, make the best choice. So let's take a look at the descriptions we have. Now what I spot right away is that F has all these symbols. Symbols such as equals, equals, non-equal, blah, 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 used to compare values in conditions. This looks like comparison operators. That one looks easy, so I'm gonna get that one out of the way first. Okay, a structure that executes one block of code if a condition is true and another if it is false. Let's see. If else. This is probably an if else clause. All right, we should probably be doing these in order, but process of elimination can be helpful in these. Okay, a conditional structure. Let's do a conditional structure that allows for more than two possible outcomes by checking multiple conditions sequentially. This is going to be, okay, that's not a simple if statement. A condition that allows for more than two possible outcomes by checking multiple conditions sequentially. All right, it cannot be if else. And the reason is because else does not have a condition. So it's probably if elif else. I could see that if elif would also fit this, but it is not listed here. All right, so also have done. E is finished. All right, so I think A goes here. So let's cross that off. A condition that allows either to true or false, often used in decision making. This is the definition of a Boolean expression. Could also be branch guard, but Boolean expression is the thing that is listed here. So I'm gonna go with that. Okay, a structure where one if statement is inside another. Oh, this is totally nesting, allowing more complex decision trees. Yeah, this is nesting. So we go to nesting and all we have is a simple if statement left. So let's get rid of C. And now let's take a look at this. A basic decision-making structure that executes a block of code only if a condition is true, otherwise it does not. So that D goes right here. Okay, very good. I think they all fit. So I'm also gonna just check this against what I gave you in the answer key to make sure we are all in agreement. So we'll scroll down. Let's go. Oh, yeah, right here. Section C, number 10. DEA, CBF. Good. Okay, so it all agrees. It's always great. Okay, now let's move to the next. So this is short answer. Choose 3 of 4. 6 points each equals 18 points. Again, notice that there's a choice here. So you want to pick something that is going to be the easiest. So you have string slicing to do, debugging, which can sometimes be difficult, loop behavior, one to skip a few. So this one is going to be doing some counting. You have to write a function. All right, so of these, scanning them, I think writing this function is probably going to be hard, and the debugging is probably gonna be hard. So if I were you, I would probably plan on skipping one of those two. All right, so this one is a string slicing. So let's see what we got to do in this one. We have Pythonic written up here, and we have the positive indices, right? The equivalent negative index slice to extract the same substring. So remember how this is written out, that the positive indices begin at 0. That's the thing that will trip you up. So let me see if I can zoom in. Oh, I can. I'm gonna just go ahead and number them if it's will let me. Seems to need to be recalibrated each time, I think. 0, 1, 2, 3, 4, 5, 6, 7. -1, -2. Yeah, this is hard to read. -4, -5, -6, -7, -8. Okay, so my numbering is correct. This one goes from 0 to 7, and this one goes in the other direction from -1 to -8. So this first one is going from 0 up to, but not including 3. So this is actually slicing out P, Y, T. So what are the indices for T, for PYT in the negative? It's -8 up to, but not including 8, 7, 6, -5. So -5 matches the 3. Yes, is that correct? Yes. Okay, good. It didn't ask us to fill this out, but I think it's a good idea to write it all down. Okay, 4 to 7. So we start at 4, O, N, I, but not including up to, but not including 7. So that one also is just 3 characters. So this is -2, matching down to O, which is -4. Let's see. Ah, I did it wrong. I did it wrong. They have to start on this side. Because remember, you always have to go from the left to the right. So to slice O first, we do -4. And then we go actually to the end. So you could, no, you don't. You go up to -1 because we need to leave one off. So we go from -4 up to, but not including -1. Okay. From 1 to 6, why? Why is this not working now? I'll change the battery. This should be working. No, there we are. Okay. So here we're gonna go from 1 to 6. So Y T H O N I. I is a 6 1. Nope. So we stop right there. Right, Y T H O N. So we're gonna go now from 1, which matches to -7. Jeez Louise, what's going on with this thing? Oh, because I have the eraser. That's why. Yep. Okay. Y. Y starts at where? -7. -7. Up to, but not including N, which is 5, which happens to be also -5. Okay. Now this one goes from 3 to the end. So this has a 0, 1, 2, 3, 8, 7, 6, -5. So +3 is H, and this is -8, -6, 8, 7, 6, 5, -5 to the end, which also we can just leave blank because that will also go to the end. So we'll leave that blank on purpose. here we have word from the beginning up to but not including 4. So that will be -8 up to but not including 4. It's this one. It's the O. So the O is lined up to the +4. Wait, I think I did not read my writing correctly on this one. I think one of my indices is wrong. All right, let's just continue. Okay, word from 2 to 5. So 2 starts at T, which matches to -6, and 5 matches to -3. I think I misread something in here. All right, let me just take a look. -8 to -5, -4 to -1, -7. Yeah, it's this one. There is a mistake in here. Let's recount this one. To 6, that is not -5, that's a 2. -2, okay. 3 to the end is -5 to the end. -8 to minus. Wait, this one is negative indices. I forgot the negative sign. There we go, -4. So you also could have left this one blank because we're going from the beginning. So you could also left a dash. So +4 is also -4. Okay. Word from 2 to 5 should be -6 to -3. Okay, so that is now correct. All right, good. So you see that the key thing here is just writing it out and numbering it, which was a little bit clunky with the stick pen. So just make sure you bring a nice big pen that you can use for the numbering. All right, next, debugging. Oh, I love these. So let's take a look. The following function is supposed to return a string with only uppercase letters from the input. However, it contains errors. Edit and fix. All right, so let's scroll down to the next thing here. All right, so let's take a look at what is happening here. It should only return uppercase letters. This is very close to some of the other things that we looked at. So this is using dot upper. Now, the first problem that I spot right away is that the upper is not done correctly, right? This should be a function. Part of the issue is that this thing keeps flipping in and out. Okay, the upper should be a function like this, right? And then we can have that if character dot what we want is upper, not uppercase. So we will need to do that is upper with the parentheses. So this is going to check whether it is. Otherwise, it simply would have tried to cast it to being uppercase. Now, look at what we're doing here. Here we are concatenating on the character. Is that what we want to do? If it is uppercase, we would collect it in an accumulator called result. Here's the accumulator result, which is here. So that looks good. All right, I don't think there are any other corrections that need to be made. Let's just trace it through. We have a string that comes in. We check the signature, string to string, returns a string with uppercase letters. So here result is the empty string for character in S. So it's going to cycle over that. This is correct. This kind of loop does in fact have the character. We ask whether or not it is uppercase. We have the parentheses now gone. We would collect the character. So if it is an uppercase, it will collect. Otherwise, we'll go back to the top of the loop. If it's lowercase, then it would simply, this would be false, and we would go back to the top and we would not accumulate. So this looks good. And let me just double check the one in the script that I did run, which it is good. Okay. So that's basically what you need to do. Then we might write a brief note. Use is upper, not upper, to check if it is uppercase. Okay, use the parentheses for functions. So that's the kind of note I would be expecting. All right, loop behavior. What will the output of the following code be? Right, the output and explain why the numbers appear in that order. Okay. So let's take a look at what is happening here. So count begin, okay, it's no function, so there's no function call. Count begins at the number 10. Okay, well, count is greater than 0. Is 10 greater than 0? Yes. So we do what it says. If count %2 equals 0. So this is asking about odd or even. Is 10 divided by 2 having no mantissa? That is correct. 10 is an even number. It will print count, so we'll print 10. Count minus equals 1. So it might also be useful for us to keep track of what this is. So count will be down to 9. Back to the top. Is count being 9 greater than 0? Yes. But 9 is not evenly divisible by 2, so it will not print. Back to the top. So you can start to see what this is going to do is print the evens. 10, 8, 6, 4. Continue it over here. 2. Now let's watch very carefully. So it prints 2. Count minus equals 1. So now count is 1. Is count greater than 0? Yes, it is. Is count being 1%? 2 equal to 0? No, it's not. 1 is not evenly divisible by 2, so it does not print. Now we subtract, and now the count goes down to 0. Count is no longer greater than 0, so this becomes false, and that's the end of the while loop. So actually we could have just squeezed this 2 in down there to make this a little simpler. All right, now I need to write an explanation, just so it doesn't mix up. I'm gonna switch colors. So, what kind of explanation is happening here? So, counts down by 2s because of the if block. Okay, %2 checks for even. %2 equals 0. The whole thing really checks for even. If yes, print, else goes back to top of loop. So something like that would be the kind of thing that I would be looking for as you're explaining how this works. All right, great. Want to skip a few. Now keep in mind that you do not need to answer all of the questions in the section. You get to skip something. So if you did decide to skip one, like maybe you weren't that confident about it, please just, do something like this or cross out even just the answer, especially if you've written something on it. You don't need to completely obliterate it. If you've written something and I can see it and that you've marked it that you don't want me to grade it, I often will just comment on it to tell you if you got it right or not, but I won't include it in the grading. Okay, 1, 2, skip a few, right? Function skip counting that prints the numbers starting at 3, skipping every third number up to 30, using a for loop with range. All right, so what we are doing here is for x in range. Now, keep in mind we need to start. Let me just write this underneath. So we should be using the start, stop, and step. So we would put start. That will be the start. Next will be the stop. And next will be the step. Right over the edge of the page, just like that. All right. So now what we need to do is we need to figure out what exactly goes in these blanks. So we'll be starting at 3, so that one is easy, right? And we also are counting by 3, so that's why this will be 3. Now, we go up to 30, but not including 30. So this output right here is a very good clue because we go up to but not including 30. So what we can do is, knowing the stop goes up to but not including the mark, is put a number there. So we go up to but not including 30. So it should be for X in range 333. Excuse me. All right, let's see. Just gonna make sure I am giving you all the answers that match to what I have given you. Okay, so in the solutions I see for number 13, I've also given you a step-by-step execution written out, so you can also refer to that, which is useful. Skip counting. Okay, I have 31 in here, which I disagree with in the solutions, because that would include 30, and this one clearly does not include 30 in the sample output. So I actually am going to change that because I disagree. If the output does not have 30 in it, you can put anything between 27, 28, 29, or 30. So it should be 333 like this, because it goes up to but not including 30. So 30 does not print. So this is how this ought to be. Okay, next is the code writing. So actually I'm gonna pause this because I don't have the code all typed out, and you probably don't actually want to watch me type all the code. So let me just go ahead and pause this. Let me stop the sharing. Hello. Now let me pause the recording, and I will go and get the answers for you, and then we can talk through those. All right, hold on one moment. All right, hello everybody. I'm back. What I've done is gone ahead and gotten my solutions for the code writing, and now we will go through those. So let me share my screen again. And let me all right, so I actually have the questions in 2 places. I have the questions here, and I have them on another screen that I'm not sharing with you because it's on a different computer. But you probably have both up. Okay, so what I did notice though is I did go back and just double check this one to skip a few questions. It looks like in the original solutions that I had intended to change that up to skipping with 4 and stop at a different number. So there was a bit of a mismatch there, but as written, the skip counting question does have starting at 3 and going up by 3. So the solution that I gave to you is correct, and it may not be correct on the one that's in the Google Drive. So this starts at 3 and goes up to but not including 30, as the output clearly suggests, right? So that does not have that. And you're counting by 3s. So anyways, I will repost that. I'm sorry if there was some confusion on that, but hopefully that's now more clear. All right, so that is that's that. So now the next thing we want to do is go to the code writing part, which is down here. So the first thing that I would do when I get the code writing, or even when I get the exam, is screen through them to see which ones are gonna be the harder versus the easier ones. Okay, so writing a custom function absolute value is the first thing that you have to do. So for this one, I cannot use the built-in absolute ABS. So I could, however, determine whether it needs to change the number sign just by using if blocks, right? If it's less than 0, I need to return -1 times the number, otherwise just return what it gave. So that one looks like it's probably going to be pretty easy. And here are the checks. You do want to run your test cases to make sure it's running right. Okay, triangle printer is going to print a triangle. This is a much easier version of Diamond in the Snow that you did on your homework. So basically, I think all it needs to do is use repetition. So this one, I think, should not be that hard to solve. The next one is name formatter. Write a function format name. It takes the first and the last name and then returns a properly capitalized full name. So capitalizing the 0th position will be easy, but capitalizing the next one is going to require doing some slicing. So this is probably going to be solved with a range, and that is going to be a harder one to get correct. So if I were going to throw one out, that would definitely be one of my candidate ones, because that will take some doing. Okay, this one is word count in a sentence, right? Word count that takes a sentence as a string and counts the number of words being separated by spaces, number of letters, ignoring spaces and punctuations, number of non-letter characters. And it should be string processing and not built-in Python functions. So that means not using split, and it also means not using lists. So those things we have not covered in the class. And part of what we're asking here is, how do you suppose these things are working? So this one's going to be a little bit challenging because, again, we're probably going to need to solve this one with slicing. It has some similarity with needle in a haystack. So, with that in mind, if I were you, I would be thinking between 17 and 18 as the ones that I would be throwing out by scanning those like this. All right, so let's see how this is looking. So let's get down here to my absolute value. So this is number 15. My absolute value, as we had noted, just scanning over it, this can be handled using if blocks. So here we have an if block of n is greater than or equal to 0. We would simply just return n. Otherwise, we would return -n, which will flip the sign of this. You could have -1 times n, that also is fine. So here we have a couple of test cases that we are running to test and make sure it is doing fine. All right, next up is number 16. This is the print triangle. So what we want to do in this example is to print out those triangle pictures. So what we might do is we might start at 1. Okay, so remember thinking about the idioms. It's very unusual to start at 1. So why would we be starting at 1? Because we're going to multiply the star times the I. So we'll start I at 1, which would repeat the star 1 time, which is what we want for the apex of the right triangle. And then we're going to go up to n, the number that they've given, plus 1. So if we want to have 4, remember, this will go up to, but not including the end. So we need to go up to n plus 1 to make it print the whole thing. And we'll simply just use repetition. So this one also is not too bad if you can recognize this is a range problem. Then, of course, putting our correct signature on, and it's going to be an integer, the number of stars you want to see, and it's returning an untype because the job of this function is to print. All right. Next, okay, oh yes, one other thing. Notice that I didn't wrap this in a print statement here, because if this were inside a print, it would print that extra none, and that's because the function in fact returns a none. It returns none, which has none type. So you don't want to put this in print because the function is returning none. So you don't need the print. The print is happening inside the function. Okay, so in that hints at why putting the signatures on can be really helpful. Okay, next is number 17. So this is the formatting the name. This is a tricky one. Formatting the name is going to be a little bit hard because you're going to have to get the context right. So if you were in a bind and you have to answer this question or you're running out of time, you should at least start with the easy things. So for example, capitalization, I think we can assume, excuse me, that the 0 character needs to be capitalized. So at least do that, and I can give you at least some points. All right, now there could be a couple of different ways to do it. This one I'm doing for the index and range of length of the string. So that may be a good way to do this. All right, so let's take a look at how I'm processing this. If I equals 0, that is if we are at the 0th character and it's somebody's proper name, then we might assume that that should be capitalized, right? So, or if name in the position before equals a space, then we would append dot upper, the dot upper version of it, right? So here's Alice Johnson. Here we have I of 0, that will be A. And notice that I minus 1 position will be equals a blank will happen when the J occurs. So here we have the formatted name plus equals name dot of I dot upper to move that along and collect those characters. If it is an alphabetic character, but it's not first, then we would make it to be lowercase. So that's why I'm checking is alpha. So it means in the lowercase letter that is not uppercase. And see that if we use it in this chained if block, this actually works really well because this catches the case, right, that is not the beginning or the one after the space, because only one of these branches can run at most. So that's why it's very important this is chained. So we would then collect that. Okay, then finally we have else. So this would be whatever else is left over. So for anything that is non-alphabetical, that's what would land over here, because anything that is alpha either got caught up here and got capitalized, if it's the first or after space. This is alpha checked for all the alphabetic characters, so any alphabetic character would be here, and then this will take on anything that is non-alphabetical and just accumulate that just the same as it is. So that's our for loop, and that's how we could set that up. Then this will return the formatted name. So here are some of the test cases that we've given. So you can go ahead and check those, and we will run that at the end of this. You, of course, should be doing run module as we go along. But to keep things moving, I will not do that right now. Then for the next question, we have word count in a sentence. So this is going to count the words, letters, and non-letter characters in the given sentence. So let's see. We need to initialize counters for each of the different things. Word count is going to be set to 0. Letter count is 0. Non-letter count is set to 0. So similar to how we did the question before, probably having some kind of if block will be useful. If in word equals false, this checks to see if we are inside a word or not. So we may want to modulate back and forth to being inside a word on the basis of something. So let's see how we can do this. So here we're going to cycle over for character in string. We do not need any information about the position in the string, so that's why I chose this. Keep in mind that the character is actually the character, it's not a position. So if the character is alphabetic, then we could add 1 to the count. If it's not, so here we're checking whether or not we're in words. So this is like works like a little toggle. If we were not already in a word, then we would start to be in one. So now we're going to add word count plus equals 1, and now we've flipped this switch for in word from false to being true. So this is how we're going to tell, and we're going to switch. So any non-letter character, punctuation, spaces, numbers, and so on, we would have non-letter count plus equals 1. So that would increment our non-letter count. That's this non-letter count right here. Our word count, you see, is incrementing right here, and the letter count is incrementing right here. So that gives us our ways to increment each of these. So yeah, that basically is how we can set this up. Notice that this one is indented inside this if block, right? So if you're not in Word, we would we would um, flip that over because it's an alphabetic character. If you don't have a character, you see that it will flip to false over here. So that's how that one works. That one is a little bit tricky, and probably you would want to debug that a little bit. So yeah, that would be one of the ones I would consider not answering. Okay. And let's take a look at our temperature feeling one. I think I did not read over this question before. Temperature classifier. We also have this option, right? A function temperature feeling that categorizes the temperature into very hot, warm, cool, cold, or freezing. Okay. Oh, this should be fairly easy to deal with by using a chained if block. So here what we're going to do is simply just make some mappings with the greater than and or equal to, right? So we have very hot for that temperature, and now I'm going to make the range. I'm going to test all of these ranges to see where my value falls, and yeah, this is how we do it. And if something isn't caught by any of these, it will be left over and caught in the freezing. So let's see. This one is fairly equal. Okay, so okay, write the function and implement the function. So there's the function implemented. Now the next thing we have to do is part B, prompt the user for input and validate that it is a number. Keep asking for input until a valid number is entered. Okay, so to deal with this part, we're gonna get valid temperature. So while true. So this is really the best thing you want to do if you have a situation where you are asked to repeatedly prompt the user for some information. So here we're gonna do the while true. Temp equals input, enter temperature in degrees Fahrenheit. So hopefully the user will type something, and then if temperature is a digit, we will convert that into temperature. So basically this is going to screen for if the user types a temperature that's not numbers, right? So if they type, I don't know, FIVE, right? It will cause a problem here, right? Because the issue is if you attempt to do int on a string, that it's unable to convert like FIVE, you are going to get an error. So this is why we would want to do that from a practical standpoint. And now here we would continually tell the user to enter a number. And here this is continuing to do that process. And then we would categorize the temperature by simply just asking the user to get the number, and then we would prompt the user, then we would just run that through the function above, which in my screen is blocked below the zoom control. So let me just try to bring this up a little bit higher so you can see it. Here we go. Right, so here is the function call get user. User temp is get valid temperature, and then we would get the user's temperature by using this function that will continually prompt them, and then we can print out the temperature fields, and then we can send the answer of whatever number they typed by sending that into these sorting right here. All right, so what we should do is, of course, make sure that everything runs. So run module. I want to save it, and there we have everything. And we're being prompted to enter temperature. What's the temperature today? Oh, it's kind of chilly. I'm gonna say it's 58 degrees. Temperature feels cool. Yeah, it definitely does. All right, good. So I hope that this has been helpful for you for going over your exam. As I mentioned, you do have 2 practice exams and 2 solutions there for you. So I hope that this helps. This one that we just went over, maybe the one that's maybe a little closer to your actual exam, but either one is a great one to do, and will get you a sense of the difficulty of the questions on the test and just hopefully give you an idea of how you should study. I've tried to give you some idea of how I would rationalize those questions as I was working through them. So I hope you find this helpful, and I will go and post this for you to use as a resource in case you can't come to our office hours tonight or just want to do some more review later on. So thanks so much, guys. We'll see you later.